This video introduced hashing, which is the process of transforming any given key or a string of characters or a set of objects into another value. In Java, these objects will be Java objects. They could also be custom class of your choice. A key is usually represented by a short, fixed length value that represents the value. These values could be the same, but the keys must be distinct. This is where hashing comes into place. In order to make a key distinct, you can think of this hashing, which is a function, let's say fh, that takes a given key and hashed into a key prime. This key prime is the hashed key that is supposed to be distinct. The most popular use for hashing is the implementation of hash tables. And this hash table contains key value pairs. These key value pairs, which corresponds to the pairs sitting inside a map. And we use array to store these key value pairs. And because an array is involved, your retrieval and removal typically involves all of one operation, because you can simply use the array's index to locate the data you need. Questions: how would you store key value pairs inside an array? As we talked about earlier, your key could be the array index, such as ARR index I being its key, and your value will be the data coming out of the array sitting at this key location. With that in mind, we can simply just use array indices to fetch the data we need sitting inside this array, which is the underlying data structure for implementing a map ADT. Question: how is hashing involved in all of this? Hashing allows you to generate a set of unique keys. So for every key that you push through this f of h, you'll be getting a key prime. And the reason why we need to ensure that a hash key must be unique is so that we can fetch the specific value associated with that unique space inside the array. Remember, the most popular use for hashing is the implementation of hash tables. The hash tables stores key and value pairs in a list that is accessible through its index. Because key and value pairs are unlimited, the hash function will map the keys to the table size. A hash value then becomes the index for a specific element. We'll look at an hash table construction, but before that, let's look at the compression function or this hashing function in more details. A compression function is a hash function that generates new values according to a mathematical hashing algorithms. From our previous slide, our FFH is the compression function described herein that takes your input, which is ID num, this is the key, modding it by 100. This is a very simple mathematical algorithm that hashes every input number by 100, producing a value within range. For example, an ID number of 50704, modding it by 100 gives you 4. This allows you to hash your key to a key prime that sits at this location. You can also have key double prime, triple prime sitting at various different locations up until 99, because modding it by 100 simply gives you any number between the range of 0 through 99, excluding 100. This simple algorithm is not complicated enough. As you can imagine, if I produce another number, 704, this will also hash into this location, which is not good. This means my values will then be duplicated here, or at least the latter value will override the previous in this slot. This is the reason why we want this compression function to be as unique as possible. It does not have to be complex, but unique in the sense that it will produce a unique key. This sort of compression function is what we call one-way hashing, because it doesn't reverse its effect. Once hashed, you don't know what the original key was as an input. Question: where is compression function used or hashing used? It is used in data retrieval. It is also used in cybersecurity or CyberSec, IPsec, and lots of other applications such as cryptography, digital signatures, etc. In the next video, we're going to look at what to do when your compression function cannot generate a unique key such that multiple keys map into the same key prime, resulting in your values being colliding with each other at the same spot. This is what we call collision. we'll look into that more in the next video.